Now that we learned some of the basics of the Linux boot process, we'll just take a quick peek at the kernel as it runs on the system. We're not going to spend a lot of time learning about the kernel in this live lesson, as it's usually somewhat transparent to the system administrator, but it is good to know some important things about the kernel as it's running. So we'll switch over to our Vagrant box. We'll log into the CentOS system. If you recall from the last slides, we remember that the kernel starts up several processes. These are internal to the kernel and are transparent to the user in most ways. However, we can still see them with the PS output. We'll use the PS command and the AUXW flags, which you can look up in the PS man page, and we'll take that output and search for just the special square bracket character, which you recall from our regular expression tutorial. The backslash is indicating an escape character. So these processes are all kernel processes, not used by users directly. We don't need to go through the details of what all of these kernel processes do, but we can pick out a few examples. kthread-d manages kernel threads. md/0 manages the RAID subsystem. kswapd manages any swap space available for overflow from the RAM. There's many other kernel processes in this list. These generally don't impact the system administrator. Sometimes if a system is misbehaving, you'll see some process like the kswapd process running out of control. You'll see that in the top output, which we'll talk about later. That's really the only time during standard administration duties that you'll encounter these processes. Next, I briefly wanted to touch on kernel modules. Modules are located in /lib/modules. There's one directory for each kernel. As you recall, we're currently running the 358 build of the kernel. So if we change to that directory, we can see a whole lot of files. These are all very specific drivers that the kernel has available for hardware attached to the system. Not all hardware is created equal. For instance, a network card created by Intel differs in many details from a network card created by Cisco, or yet again from a card created by some other company, perhaps Broadcom. The drivers for each one of those cards is located in this directory. Again, this is a place where most administrators don't need to edit very often. Modern hardware comes naturally to the Linux kernel. However, there is the occasional situation where you might need to make some kernel changes. In that case, it's good to know where these directories are. Now, these modules are loaded by the kernel at the boot time. It doesn't make any sense to load a Broadcom network card if we don't have any network card attached to the system. So you can see which modules have been loaded by typing sudo to run this as the special super user, and then we type lsmod. It doesn't matter that you don't understand all of the details of this output, but we can see on the left side which modules are loaded, the size that they're taking in kernel memory, and what other modules depend on it. In the event that you need to edit drivers on the system, lsmod and the modprobe command are how you accomplish that. Modprobe adds and removes modules from the kernel. One place that system administrators do encounter frequently is the concept of synthetic file systems. Most file systems, like the boot file system or the root file system, are real file systems that live on some disk. Synthetic file systems are virtual or fake file systems created by the kernel. It's a way for the administrator to access the internal variables within the kernel. One such file system is /proc. The /proc system is meant for process information. It's an interface into the kernel's data structures. If I list the contents, there's a whole lot of files in here. You'll see a lot of directories with numbers. These are all just process IDs. If you recall from our last slides, process ID 1 is the init process. So there's a directory /proc/1 that contains details about that process. If we looked at some command within there, for instance, if I cat out proc1 and then the file command line, that shows me exactly how that process was invoked. In this case, it's the init process. In addition to the process ID file systems, there's many other tunable kernel configurations that we can access in /proc. For instance, in /proc, /sys, /net, /IPv4, kind of a mouthful, this is a commonly accessed place for a system administrator to change IPv4 tunables. If I list the contents of this directory, you'll see a lot of very special files that I can use to change how TCP or IP or similar protocols work. If I type cat TCP mem, this shows me a specific TCP tunable value. A common one is IP forward. In this case, this system doesn't allow IP forwarding, but often on a system that might act as a firewall, for instance, you would enable this by setting IP forward to 1. Another synthetic file system is /sys. /sys is much like /proc, but it's really meant for devices and buses and drivers, also known as kernel modules, as we just learned, and how you can configure those. So it has a slightly different use case, but the intention is the same. You use it to manage configurable values used by the kernel.